Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss the concept of inclined plane surface when it is submerged in the liquid. So in our previous lectures already we have discussed regarding the horizontal plane surface and vertical plane surface when it is submerged in the liquid. So let me give a just brief explanation about that. So this is the free surface of the liquid. Okay, so this is the free surface of the liquid, and when the plane is vertically, then we can say let's consider a rectangle is there. Now this rectangle is placed vertical to this plane surface. Okay, or we can consider any kind of object which is placed vertical to this free surface, and we have considered some small strip on that, small area on that we have considered. Okay, similarly here also you can consider. So here what I mean to say, this plane surface is perpendicular to the this liquid surface. That means it is vertically placed inside the liquid, and when the liquid is in the rest condition, that need to be remember. And here we have taken the center of gravity point and the pressure point on this. And similarly, this is about vertical. Horizontally, how we have taken? Horizontally, we have taken a plane like this, and it is placed on this way. Okay. Now the height from here, from this free surface to this horizontal plane, everywhere is same. Everywhere it is same. Okay. So this is about the horizontal surface. This is about the vertical surface. Now we'll discuss about the inclined one. When inclined plane is there, now how we can identify the total pressure acting on that, and what is the center of center of pressure and the total force acting on this. Now here what we have taken, this is a plane surface is there, like a liquid surface is there. Okay, and to this liquid surface there is a inclined plane which is kept here, and this plane surface, or you can say any kind of plane can be taken here. So here an arbitrary shape of this plane was taken here, and on behalf of this we can take a circle can be taken, rectangle can be taken, anything can be taken. And on this plane surface, this plane surface makes an angle of theta to this free surface of the liquid. So theta is the angle between the free surface of the liquid to the inclined plane. Okay, inclined plane surface. And G is the point of the center of gravity, and the center of pressure is P point, and OO is the axis line, you can say, which is perpendicular to the free surface of the liquid. Okay, this one, it is perpendicular to this free surface of the liquid, which we have placed in with an angle of theta. Okay, now the distance from this point, free surface of the liquid, to this center of gravity, that is y bar. So here some notations will come to the picture, like A is the area. A is the area of the total area of, you can say. Okay, I'm not writing, I'm just telling what are the notations will come and how to denote this one. A is the total area of the inclined plane, and similarly, H star. H star is the distance from the free surface, to the center of pressure. Okay, similarly H bar. H bar is the distance from the free surface of the liquid to the center of gravity. Okay, now next is H. Height will be there, H will be there. So H will be from here, from this liquid surface to this where it started. Okay, where the strip is started here, that point up to this point. So H is the distance from the free surface of the liquid to this strip. Okay, similarly this is about the distance of that, and theta is the angle between the free surface of the liquid to the inclined plane. Okay, and now dA is the small area of the strip, and the dy is the height of this strip. Okay, and now see why, similarly how we have taken this H star, H bar and H, similarly Y star and Y bar and Y. These are the distance from this axis line of OO to this, see, y equal to from the center point from this axis line to this strip. Okay. Similarly, y bar is the from this line distance from this line to the center of gravity, and similarly y star equal to the distance from this OO line to the center of pressure. Okay. Now, what you need to calculate here actually, we need to find out the total force acting on this, inclined plane, and also we need to calculate the center of pressure of that. So first we'll calculate the total force which is acting here, and then we'll go for the center of pressure. So to calculate the center of total force here, we know that we'll start from the pressure acting on that. So we know that the pressure intensity on the strip. So let's write the pressure intensity in the strip equal to rho GH. We know the formula, pressure intensity equal to rho GH. Now we need to calculate the pressure force which is acting on the small strip. So next we write the pressure force acting on the strip. What we can write? So we know that force equal to pressure equal to force by area. So we can write force equal to pressure into area. Now when you're talking about the small strip, a small area, that means we can write the pressure force acting on the small strip. So that we can write dF, a small force, which is equal to P into dA. Okay, P into dA. Now we'll put the value of here. So let's write the pressure equal to what I can write, already written here, then not pressure, here we need to write dF equal to P value, we can write rho GH dA. Okay, now this is the force which is acting on the strip. Now what will write? The total pressure force. The next one is the total pressure force acting on the strip equal to integration of this, nothing but integration of dF integration of rho GH dA. Okay, now what I'll do here, let me write integration of dF equal to F here, and rho G, let take it outside, integration of HdA. Now again one more point is there. As I told you, the height of this, let's consider this is a triangle is there, the line. Now see, from here to here, suppose this is a line is there, and this line height is there, and this is the inclined line is there. So this inclined angle is theta degree. So if I consider this triangle, here angle is theta, and here height is how much? H bar suppose, and here inclined length is y bar. Similarly, on behalf of h bar, it can be also h star, and also you can write h also. So similarly, y bar, you can write y also, y star also. So now what I can write, sine theta equal to, if I want to write, then I can write h by y equal to h bar by y bar equal to h star divided by y star. So here what I can write, again one more term, h equal to y sine theta. Okay, similarly also I can write h bar equal to y bar sine theta, and h star equal to y star sine theta. Okay, these are terms I can write from this triangle. Okay, now next what will write? Now here HdA is there, so S value I can put it y sine theta. So now rho G integration y sine theta on behalf of H. Now we can take again sine theta outside, so we can write rho G sine theta integration of y dA. I can write y bar a, because I am doing the integration of this total one, the total force which is acting on this plane surface. So this integration I can get it y bar and integration dA, that is a I can write. Okay, so what I got here, F equal to the force acting on that, we can write rho g y bar a sin theta. Okay, this is the equation what we got here. Now again y bar value is there, y bar equal to, no, y bar sin theta, y bar sin theta, what I can write, y bar sin theta, y bar sin theta, I can write h bar. So again F equal to what I can get, rho g a h bar. So this is the force what is acting on the inclined surface. Okay, now we'll go for calculation of this center of pressure, center of pressure. So center of pressure is again similar things need to be considered here, but here we need to consider the moment. Okay, so first let's see the pressure force. Okay, the pressure force on the strip already we have calculated. Okay, the pressure force, this one, on the strip we can write dF equal to, already we got here, that is rho gh dA, rho gh dA. So h value we can write y sin theta, so also we have written there rho g y sin theta into dA. So this is the pressure force which is acting. Now again if you want to write the moment of the force dF, the moment of the force dF, okay, at this point what the moment is acting on that. Okay, so that one we can write what, moment acting on the force dF equal to, okay, about the axis, about what, about the axis of OO, about the axis of OO, because it is, if you take an other side then it will be different. Okay, which axis we need to consider, that one you need to write. So at this strip what is the moment is acting, that means what is the height of this and what is the force is acting on that, so that is the moment. So that one we can write, what we can write there, that is dF into the height y. So dF value already we got here, rho g y and sin theta into dA into y. So again it will become y square sin theta. Okay, so this is the moment of the force. Now again we need to find out the total or the sum of moments. Okay, the sum of moments or total force or the total moment of force, about the axis or about the OO point, about the OO point, what we can write, just you integrate this, that's it, integration of rho g y square and sin theta into dA, and this one again we can write rho g, take it outside, and sin theta also you can take it to outside, and here we can write y square dA, y square and dA. So let's go to the next slide. So here what we can write, the y square dA integration, y square dA is nothing but, if you see from here to here the y distance is there and the area, small area is this one. Now this integration of y square dA is nothing but, we can write y square dA integration is nothing but the moment of inertia, the moment of inertia of the surface, the moment of inertia of the surface, which we can indicate as I naught. Okay, so this is the moment of inertia of the surface. So now what I can write here, actually let's go to the previous slide. Yeah, so this was the sum of moment of force along the axis, this one. So what we got? Rho g sine theta. So that one we can write rho g sine theta I naught. This one we can give one equation. Previously have you given an equation? On this one, equation 1, this is equation 2, and this one equation gives 3. Okay, now again we can write what? The moment of total force. Let's write the moment of total force. Now see, let's go to the diagram again. The moment of total force here, force is acting here at C, force is acting at this point, the center of pressure here. Okay, and the center of pressure is situated with a distance of y star here. So what are the moment of force acting on this point? We know that moment of force is force acting on the point into the height or the distance from the axis. So moment of force equal to, we can write F into y star, F into y star, give this equation 4. Now we'll do one thing, equate this equation 1 and equate or compare this equation 3 and 4. What we'll get here? Now F into y star equal to rho g sine theta I naught. Also you can write y star equal to rho g sine theta I naught divided by force. Okay, now we also can write y star equal to s star by sine theta. Now see here, y star equal to, we can write here s star, because we got s star equal to y star sine theta. So y star equal to, we can write s star sine theta. That's it. So what we'll do, on behalf of y star, you can write here h star sine theta equal to rho g sine theta, and here I naught is nothing but the moment of inertia. That one we can write I naught equal to Ig plus h bar square, what we got previously also. Okay, this is the equation for the moment of inertia. So just you can multiply this Ig plus h bar square, bracket close. Now we can write here what the value is here. Now this one we can write sine theta, h by sine theta, this is f value also we got here already. Previously we got the value of c rho g h bar, so that one you can write rho g h bar. So rho g will be cancelled. Okay, now let me write here what is h star equal to h star sine theta. Let's take it that side. So that is sine square theta into Ig plus h bar square divided by what we can write h bar, I hope. Yeah, now again we can write what, let's split it, this one. So again s star equal to, we can write sine square theta Ig sine square theta by h bar plus yeah, now here again we can write one thing, h bar equal to, we know that h bar equal to, let's see, h bar equal to y bar sine theta. Okay, so we can put the value of that one also, so that we'll get, okay, let's keep it here. Again Ig sine theta I got already, Ig sine square theta by h bar. Now again I'll write what, sine square theta h square by h. Okay, now here what I'll do, h bar value I'll keep it. Okay, what I'll keep it, h bar equal to y bar sine theta. Okay, so if you put that one value, y bar equal to, let's write it here, y bar equal to h bar sine theta. Okay, now here if you see, okay, we got here actually, this is the parallel axis theorem. This is a y bar square actually, not a y, h bar, not a y bar square actually. Okay, so now a y bar square, that's why I'm getting confusion here, what is happened, a y by square, and here we'll get ig sine square theta by a h bar. Here we'll get a y by square, a y bar square. Now we'll do one thing here. What we'll do on behalf of this y bar, okay, we can write here a h bar is there, a h bar is there. Now y bar with what we can write, h bar by sine theta. So what I'll get here, put the value of y bar square here. Now again one more line that right. So we got one thing, ig sine square theta divided by h bar plus here what I'll get, sine square theta a y bar equal to h bar. So h bar square divided by h bar into sine square theta into sine square theta. Now this sine square theta cancel, a cancel, and h bar, one h bar will be gone, only one h bar is there. So finally what we are going to get, h star equal to, h star is the distance from the free surface to the center of pressure. So h star equal to what we will get, now ig sine square theta divided by a h bar plus only h bar. Okay, this is the final equation what we are going to get for the center of pressure. Okay, only the confusion is here actually, on behalf of y I written the h bar. Okay, so this is about the center of pressure equation. If the theta value will be 90 degree, then what will get? If the suppose the question given, the theta value is 90 degree given, means that means the inclined plane what is taken here, that will be equal to the vertical surface. Now there will be no incline, that will be worked as a vertical surface. In that, because it is 90 degree, theta was 90 degree, as I told you previously. You see, this is the free surface is there. Now this is the plane we have taken, and this is the strip what we is considering. This is the center of gravity, and this is the center of pressure. So now this angle is 90 degree of this. Okay, so this is the concept of inclined plane surface when you submerge in the static liquid. So I hope you understood how to identify this total force and the center of pressure for this. If you are having any kind of query regarding, you can give a comment in the comment box. Thank you all.